Darkness. Not the darkness of midnight or the darkness of a cave. This is something else entirely. A blackness so absolute it seems to have weight. 7 miles below the surface of the Pacific Ocean, where the water column presses down with a force of over 1,000 atmospheres, where 8 tons of pressure squeeze every square inch of existence, there is a place that defies human comprehension. The temperature hovers just above freezing. No photon of sunlight has touched this realm in millennia. The silence here is not peaceful. It is primordial. It is the silence that existed before sound itself was invented. This is Challenger Deep. And on January 23rd, 1960, 2 men sealed themselves inside a steel sphere no larger than a walk-in closet and began sinking toward it. For 4 hours and 47 minutes, they fell through layers of ocean that grow progressively colder, darker, and more hostile. The descent was so slow, so terrifyingly gradual, that they could feel each 1,000 feet as a tightening vice around their vessel. At 30,000 feet, they heard a sound like a gunshot. One of the outer observation windows had cracked under the mounting pressure. But they kept falling, because somewhere below them, at the very bottom of Earth's deepest scar, lay an answer to a question humanity had been asking since we first looked out at the ocean. How far down does it go? And more importantly, what lives there? To understand Challenger Deep, you must first understand the forces that created it. Forces that began their work over 50 million years ago. The Earth's crust is not a single unbroken shell. It is a jigsaw puzzle of massive tectonic plates that drift across the planet's molten interior at the glacial pace of centimeters per year. In the western Pacific Ocean, 2 of these plates, the enormous Pacific Plate and the smaller Mariana Plate, are locked in an ancient collision that will continue for millions of years to come. The Pacific Plate is old, some parts dating back 170 million years. Age has made it dense and heavy. As it grinds westward at roughly 5 to 8 centimeters per year, it meets the Mariana Plate and does something that seems impossible. It bends downward and slides beneath it in a process called subduction. Imagine trying to fold iron. The Pacific Plate is doing exactly that, bowing under the weight of geological time and pressure until it forms a vast, crescent-shaped tear in the ocean floor. This tear is the Mariana Trench, stretching for 1,500 miles across the seafloor like a surgical incision. And at its southern end, where the subducting plate plunges deepest into the Earth's mantle, lies the Challenger Deep, a slot-shaped valley measuring roughly 40 kilometers across, divided into 3 distinct basins: western, central, and eastern. The trench itself is remote, located approximately 200 miles southwest of Guam, in the ocean territory of the Federated States of Micronesia. This remoteness has protected it. Unlike other deep trenches closer to land, the Challenger Deep receives almost no sediment from rivers or coastal erosion. The seafloor here is relatively pristine, a brown, gelatinous ooze composed of the microscopic skeletons of diatoms that have been raining down from the sunlit surface for millions of years. The numbers are staggering. Recent measurements from 2021, using the most sophisticated pressure sensors and sonar equipment ever deployed, place the deepest point at 10,935 meters below sea level, with a margin of error of just 6 meters. That is 35,876 feet, nearly 7 miles straight down. To put this in perspective, if you placed Mount Everest, all 29,029 feet of it, into the Challenger Deep, its peak would still be more than a mile underwater. You could stack 13 of the world's tallest buildings end to end, and they would not reach the surface. The Grand Canyon could fit inside it 5 times over. But depth is only part of the story. The pressure at the bottom is approximately 1,071 times the atmospheric pressure at sea level. For every square inch of surface, over 16,000 pounds of force press inward. It is a crushing, annihilating weight, that should, by all logic, preclude life entirely. Yet for centuries, we didn't know. The Challenger Deep existed beyond human reach, a blank space on our maps more mysterious than the dark side of the moon. On March 23, 1875, a British naval vessel called HMS Challenger stopped in the middle of the Pacific Ocean and lowered a weighted hemp rope into the water. The ship was on a global scientific expedition, the first of its kind devoted entirely to oceanography. As the rope played out, 100 feet, 500 feet, 1,000, the crew began to realize they had stumbled upon something extraordinary. The rope kept falling. 26,000 feet, 27,000. When it finally struck bottom at 27,000 feet, they had discovered what would later be called the Challenger Deep, though they had no idea just how deep it truly was. Their measurement, limited by the technology of hemp rope and iron weights, was off by nearly 2 miles. But it was a beginning. 76 years later, in 1951, another ship named HMS Challenger 2 returned to the area with echo-sounding equipment. By bouncing sound waves off the seafloor, they measured a depth of 35,640 feet, a figure that stunned the scientific world. This couldn't be real, could it? A place on Earth deeper than Everest was tall. But seeing is believing. And in 1960, the United States Navy decided it was time to go down there. The vessel they chose was called Trieste, a bathyscaphe designed by Swiss scientist Auguste Piccard and his son, Jacques. It looked nothing like a traditional submarine. Instead, it resembled an underwater blimp, a massive tank filled with 130,000 liters of gasoline for buoyancy, beneath which hung a small steel sphere just over 2 meters in diameter. Inside that sphere, barely large enough for 2 men lying prone, was where the crew would ride. On January 23, 1960, Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed into the Trieste and sealed the hatch. At 8:23 in the morning, they began their descent. The fall took nearly 5 hours. As they sank past 9,000 feet, the entire vessel shuddered violently. One of the plexiglass viewing windows had cracked under the pressure. Walsh and Piccard exchanged glances in the cramped darkness. They had a choice: abort and return to the surface, or continue into unknown territory with a damaged observation port. If the window failed completely during ascent, they could become trapped underwater, unable to exit the sphere until the vessel was towed back to Guam 4 days later. They chose to continue. At 1:06 p.m., the Trieste settled onto the seafloor of Challenger Deep at a depth later calculated to be 35,814 feet. The impact stirred up clouds of sediment that hung motionless in the water. No current existed here to sweep it away. The temperature inside the sphere was 7 degrees Celsius. Outside, it was barely above freezing. Through the remaining viewport, Walsh and Piccard peered into the alien landscape. The sediment slowly cleared, revealing a flat plain of diatomaceous ooze. And then, impossibly, they saw movement. A pale, flat creature, roughly a foot long, resembling a flounder or sole, glided across the sea floor. Shrimp-like organisms scattered in the lights. Life. At the deepest point on Earth, where the pressure should pulverize bone and tissue, where no sunlight has penetrated in geological epochs, there was life. They spent 20 minutes on the bottom. Then, eager to return before the cracked window became a catastrophic failure, they released 9 tons of iron ballast and began their ascent. It took 3 hours and 15 minutes to reach the surface. For 52 years, Walsh and Piccard remained the only 2 humans to have seen the Challenger Deep with their own eyes. Their dive was a milestone in human exploration, but it was also deeply frustrating to scientists. The Trieste carried no sampling equipment, no sophisticated cameras, no instruments to measure the environment in detail. It was a proof of concept. We could reach the bottom, but we couldn't study it. That would have to wait for new technology, and for a filmmaker with an obsession. On March 26, 2012, 52 years after the Trieste's historic dive, director James Cameron piloted a lime green submersible called Deep Sea Challenger to the bottom of Challenger Deep. Unlike the Trieste, this vessel was designed for science. It carried high-definition 3D cameras, sampling arms, and instruments to analyze the deep sea environment. The descent took just 2 hours and 36 minutes, less than half the time of the original dive. When Cameron touched down at 35,787 feet, he found himself on what he described as a soft, gelatinous plain. He drove the submersible across the seafloor, filming everything. The landscape was barren, but not lifeless. Small amphipods, shrimp-like crustaceans no larger than an inch, darted through the water. He saw no fish, nothing larger than a few centimeters. Just these tiny, translucent survivors clinging to existence in the most inhospitable environment on the planet. Cameron had planned to spend 6 hours exploring, but a hydraulic fluid leak obscured his viewport and disabled the sampling arm. After 2.5 hours, he jettisoned ballast and began his ascent. Even so, his dive revolutionized deep-sea exploration. The footage he captured revealed a world unlike anything on Earth's surface, a realm where evolution had taken a different path. But the most intensive exploration of Challenger Deep was yet to come. In 2019, private explorer Victor Vescovo embarked on the 5 Deeps expedition, a quest to reach the deepest point in all 5 of the world's oceans. His submersible, Limiting Factor, was the most advanced deep diving vehicle ever built. Made with a titanium pressure hull and capable of carrying 2 people, it was designed for repeated dives, something no previous vessel could accomplish. Between April 28th and May 5th, 2019, Vescovo made 4 separate dives to Challenger Deep. On his first solo descent, he touched down at 10,928 meters, 35,853 feet, 16 meters deeper than Cameron's dive. He spent 4 hours on the bottom, methodically exploring what is called the Eastern Pool, one of the 3 basins within Challenger Deep. What he found there shattered preconceptions. The seafloor was not flat, as previous explorers had assumed. It was a dynamic landscape of subtle ridges, rocky outcrops rising 10 meters high, and pools of thick sediment. In some places, he encountered solid rock fields. In others, the seafloor was so soft that the submersible's thrusters stirred up billowing clouds of particulate that took minutes to settle. And everywhere, there were amphipods. Not just a few, but swarms of them. Some measured over 7 inches long, examples of deep-sea gigantism never before captured on camera. There were sea cucumbers, translucent and ghostly, undulating across the ooze. There were xenophytophores, single-celled organisms the size of dinner plates, some of the largest cells on Earth. Bacterial mats clung to rocks, forming carpets of microbial life, sustained not by sunlight, but by chemicals seeping from the Earth's mantle through a process called chemosynthesis. Perhaps most remarkably, the expedition discovered potentially 30 to 40 new species. Among them, a hadal snailfish, gelatinous and entirely transparent, lacking even a swim bladder to help it manage pressure. Researchers studying amphipods collected from the depths found they contained a compound called pseudoinositol, the same substance found in coconut palm sugar and currently being studied as a treatment for Alzheimer's disease. These creatures had evolved cellular mechanisms to withstand the crushing pressure, modified cell membranes, specialized enzymes, proteins that prevent catastrophic collapse at the molecular level. But there was something else in the abyss, something we didn't want to find. Plastic. On the seafloor, nearly 7 miles from the nearest human settlement, Vescovo's cameras captured images of a plastic bag and candy wrappers embedded in the sediment. Other expeditions have since confirmed the presence of microplastics throughout Challenger Deep. Our pollution has reached the most remote point on Earth. Even here, at the very bottom of the world, humanity's fingerprint is visible. Vescovo would go on to make 15 total dives to Challenger Deep, more than any other human in history. Each descent revealed new details, new mysteries. He discovered that the eastern pool is not a flat basin, but a complex terrain that shifts and changes. On one dive, a scientific lander became stuck in the muck, and Vescovo performed the deepest underwater salvage operation in history, using limiting factor to free the $250,000 device from the sea floor.
His expeditions have given scientists their most detailed maps of Challenger Deep ever created, with sonar data precise to within tens of meters. They have proven that repeated deep-sea exploration is not only possible, but practical. And they have confirmed what Piccard and Walsh glimpsed in 1960. The deep is not dead. It is a thriving, alien ecosystem, operating on principles we are only beginning to understand. When you stand at the edge of Challenger Deep, even in your imagination, you are standing at the boundary of human experience. Fewer than 24 people have visited this place, fewer than have walked on the moon. It is, in every sense, the final frontier of our own planet. But it is also a mirror. The discovery of life in Challenger Deep forces us to reconsider what we thought we knew about the limits of biology. These organisms, amphipods with modified membranes, snailfish with gelatinous bodies, bacteria that feed on methane and hydrogen, have adapted to conditions that would annihilate most complex life within seconds. They thrive in absolute darkness, at temperatures just above freezing, under pressures that would crush steel. Scientists studying these adaptations have found applications far beyond marine biology. The enzymes that allow deep-sea microbes to function under extreme pressure are being investigated for industrial processes. The fatty acids in their cell membranes, rich in omega-3 compounds, offer insights into human health. That skilloinositol found in amphipods, it could hold the key to treating neurodegenerative diseases. The geological processes occurring in Challenger Deep are equally significant. The subduction zone here, where the Pacific Plate bends beneath the Mariana Plate, is responsible for some of the most powerful earthquakes in Earth's history. In 2016, a magnitude 6.8 earthquake struck near the trench, reminding us that this is not a static feature, but an active, dynamic wound in the planet's crust. By studying how tectonic plates interact at Challenger Deep, scientists hope to better predict the massive megathrust earthquakes and tsunamis that devastate coastal communities. The serpentinization process happening here, where water trapped in the subducting plate is squeezed out and transforms mantle rock, releasing methane and hydrogen, may offer clues to the origin of life itself. Some researchers hypothesize that Earth's first living cells could have emerged in similar deep ocean environments, powered by chemicals from the planet's interior rather than sunlight. If true, the Challenger Deep is not just a curiosity. It is a window into our own genesis. And there is another significance, one that extends beyond Earth. The conditions in Challenger Deep, high pressure, no sunlight, extreme cold, chemical energy sources, are remarkably similar to environments on other worlds. Europa, one of Jupiter's moons, is believed to harbor a subsurface ocean beneath its icy crust. Enceladus, Saturn's moon, shoots geysers of water into space from a hidden ocean. If life can exist at the bottom of the Mariana Trench, sustained by chemosynthesis and adapted to crushing pressure, then perhaps it can exist out there too. In studying Earth's deepest wound, we are learning how life finds a way in the most impossible places. We are discovering that the boundaries we assumed were absolute are, in fact, permeable. And we are being humbled by the realization that even now, in the 21st century, there are vast regions of our own planet that remain unexplored. Challenger Deep will outlast us. Long after the last human has taken their final breath, long after our cities have crumbled and our satellites have fallen from orbit, the Pacific Plate will still be sliding beneath the Mariana Plate, deepening the trench by fractions of centimeters each year. The amphipods will still be there, scavenging in the darkness. The xenophophores will still cling to rocks. The microbial mats will still process methane and hydrogen, indifferent to the absence of sunlight, indifferent to our existence. There is something both terrifying and comforting about that.
We spend our lives reaching upward, building towers, launching rockets, dreaming of stars. But the deepest mysteries are often the ones beneath our feet. Or, in this case, 7 miles beneath the ocean's surface. We have mapped Mars in greater detail than we have mapped our own seafloor. We have sent robots to the edge of the solar system, yet only a handful of humans have seen the Challenger Deep. Perhaps that is how it should be. Not every frontier needs to be conquered. Not every mystery needs to be solved immediately. Some places are valuable precisely because they remind us of how small we are, how much we don't know, how vast and strange the universe remains. In 1960, when Piccard and Walsh reached the bottom, they proved it could be done. In 2012, Cameron showed us what it looked like. In 2019, Vescovo demonstrated we could go there again and again, transforming exploration into science. But the deep itself remains unchanged, ancient, patient. It has been there for 50 million years. It will be there for 50 million more. And in the darkness, where the weight of the entire ocean presses down, where the temperature hovers just above freezing, where no light penetrates and no sound echoes, life continues. Silent, resilient, eternal. Somewhere, right now, an amphipod is moving across the ooze of the eastern pool. A xenophyophore is filtering nutrients from the water. A microbial mat is converting hydrogen into energy. They do not know we exist, and in their unknowing, they offer us a gift. The reminder that the universe does not revolve around us, that existence is larger, stranger, and more wondrous than we can imagine. That even at the bottom of the world, in Earth's deepest wound, there is beauty, there is mystery, there is life.